Okay, if you need help on the first problem, the first thing it's asking about is the sum of the interior angles. Anytime we look for the sum of the interior angles, we use the formula n minus 2 times 180. And so in this case, all we have to do is plug the number of sides in. A nonagon, hopefully you know, has 9 sides. Get to the second part, it says the sum of the exterior angles. We're talking about the exterior angles, no matter what the shape is, they automatically add up to 360. It doesn't matter how many sides the shape has. The third problem, we're talking about the measure of each interior angle. So it looks like problem number 1, except we throw in the word each and that the shape is regular. Okay, so to do this first thing, you got to use the n minus 2 times 180 thing to figure out what the angles add up to. So for this problem, we're just going to plug 18 in for n. Once you have that, that's not what each angle measures, that's what they add up to. So then we have to divide that by 18 angles to find out what each one is. Finally, in the last problem, we're looking at the measure of each exterior angle. So again, we're going to take the total, which we already know is 360, and divide by how many sides the shape has. Problem number 2 looks like this. We have the angles on the exterior angles in a polygon. In this case, it's a pentagon, but it doesn't actually matter. We know that these angles around the outside of the shape have to add up to 360. So all we have to do in this case is take 360 and subtract the angles that we know, and whatever's left is going to be the missing angle for x. For problem number 3, we are looking at the interior angles in a pentagon. So we know it's got 5 sides, and we want to find the measure of the value of x that will make this work. All right, so first off, you got to figure out what these angles add up to. To do that, we use the formula n minus 2 times 180. Since the shape has 5 sides, we're going to plug 5 in for n. You'll get a number, it's a little over 500. Once you have that, then we got to find out what x is. And what we know is that value that you have for the total is what you get when you add up all 5 of these interior angles. So you'd write 91 plus 125 plus 92 plus 3x minus 5 plus 4x minus 8 equals that total. You'll have to combine like terms and solve for x. Problem number 4 is solved exactly the same way we solved problem number 1. You can just rewind the video and watch that. For problems 5 through 9, what we're looking at here is trying to identify which quadrilateral we're looking at. Now, in my mind, the easiest ones to spot are the ones with the right angle marks. So we see that in problem number 5 and number 7, we got a 90-degree angle. The shape that's got a 90-degree angle is a rectangle or a square. And what's the difference between a rectangle and a square? It's whether all the sides are the same or not. If you look at the 2 shapes, in problem number 7, all 4 sides are the same length, but in problem number 5, the top matches the bottom, but the left and the right match each other, but they don't all match the same number. So you should hopefully easily be able to pick out which one of those 2 is a rectangle and which one is a square. Problem number 6, one of the ones that people tend to forget, what we have here is that all 4 sides are marked the same, but we don't have a right angle. So 4 congruent sides, but no right angle. Hopefully you know that that is a rhombus. Problems 8 and 9 just have to do with the parallel sides. And the difference here is in number 8, we have 1 set of parallel sides, but number 9, we have 2 sets of parallel sides. Well, a quadrilateral with 1 set of parallel sides is a trapezoid, and a quadrilateral with 2 sets of parallel sides is a parallelogram. In problem number 10, we have all 4 sides marked congruent, and we have right angles. That means this is a square. Trying to figure out what x and y is, it's 2 parts of the question, but since all of the sides are the same, since this one side over here is 36, all the sides are 36. So what I have to do is set these equations equal to 36 in both cases. And there are 2 unrelated problems here, but they're just coming from the same picture. But in both cases, we should be left with some relatively easy algebra to solve. And yes, in this case, they both come out to be the same number. That is not always the case. You can't assume that that will always happen, but it does happen in this one. For problem number 11, we are looking at a trapezoid. And trapezoids, the angles come in pairs. So we have this top line and bottom line that are parallel to each other. And then the angles that connect those should add to 180. So what we normally have in a trapezoid is these 2 angles should add to 180. So together those will add to 180. And then over here on the right side, these 2 angles will add to 180. But the red angles and the blue angles normally don't have to match. However, This shape is an isosceles trapezoid, so this side on the left matches this side on the right, means that the angle pairs will repeat. In other words, the two measures you get for the angles on the left will be the same as the two angles that we get on the right. Problem number 12, this is a trapezoid. The line to the middle is called the midsegment, and that midsegment is halfway between the two bases. See this top base of 15 and the bottom base is 45. X, that midsegment, has to be exactly halfway between them. So in order to find it, we're simply going to add the two bases, the 15 and the 45. You add them up, and whatever you get, you divide by 2. That'll tell you the length of the midsegment. Problem number 13 says we have a parallelogram. Whenever we have a parallelogram, there's a certain pattern to the angles, and that's that the angles diagonally from each other, these two, have to be the same. So right away you know what the measure of y is. Now these other two angles, since they're diagonal from each other, they are going to have the same measure as each other, but they're not going to be 35. These angles are going to be whatever you add to 35 to get 180. So it's the supplement to 35. Problem number 14 says it's a parallelogram, and a parallelogram is a simple pattern where opposite sides are congruent. So this top part, 4x minus 10, has to be equal to the bottom part, 3x plus 5. These two are going to be equal. Put an equal sign between them and solve for x. Likewise, the left and the right sides have to match each other as well. So this 6y minus 10 has to be equal to the 3y plus 20. Set those equal to each other and solve for x as well. Problem number 15 is, again, a trapezoid, but it's a little bit different. In this case, we know the length of the base and the mid-segment, but what we're looking for is the length of the other base. Now, this one's a little bit backwards. It's actually not very difficult, but you have to realize what's happening here. This 28 is halfway between the 21 and the x. So however far it is from the 21, however much bigger it is, x will be that much bigger than 28. In other words, in this problem, to get from 21 to 28, we have to simply add 7. This is just add 7 to get here. So to get from the 28 down to x, we're simply going to add 7 again. For problem 16, we have a trapezoid again, and just a reminder, the angles come in pairs. These two angles have to add to 180, so you can find x by simply subtracting the 127 from 180. These two angles also have to add to 180, but they don't have to match the red ones, because it's not an isosceles trapezoid. So you find y by subtracting the 41 from 180. Okay, problem number 17 has 3 parts to it. Luckily, none of them are hard. If you do them in order, in this alphabetical order, you start with the x. This 4x plus 7 on top, the length of the top side, should be equal to the 8x minus 1 on the bottom. Just set them equal to each other and solve for x. For the y's, same thing. This 2y plus 20 on the left should be equal to the 56 on the right. Set them equal to each other and solve for x. The one that's a little bit trickier here is the 30z, but it's not really that hard. This is an angle in a rectangle. That means this 30z has to be equal to 90, because its shape shows a rectangle. You even see the 90-degree box in that corner. Just set it equal to 90 and solve for z. For problem 18, this is the 3rd time this year we've seen this problem. What we have essentially here is a right triangle, and in order to find x, say this is a right angle and x is the hypotenuse. So in order to find x, we've talked about a couple different ways we can do this. And probably the easiest is to just do the Pythagorean theorem, 8 squared plus 8 squared, and take the square root. If you remember the shortcut triangles, this is a 45, 45, 90 triangle, so you can jump straight to the answer. If you really wanted, you could identify that these the angles in this picture, since the sides are the same, you could recognize that these angles are 45, and you could use SOHCAHTOA to find x. So there's several different ways you could do problem number 18. Number 19 is kind of a backwards problem. Normally when we talk about the exterior angles in a polygon, what we do is we take the total of the exterior angles, what they add up to, which is 360 degrees. If we want to know the measure of each individual one, we divide by how many sides it has, and that will tell us what each angle measures. But in this case, we don't know how many sides it has. Instead, we know what the angles measure. So what we're going to do is simply swap these two, and you can know what the angle is. It's 135 degrees. So we take the 360 and divide by the measure of each angle, and that will tell us how many sides the shape has. Finally, our last problem, number 20, we're looking at exterior angles again. We know that all these angles together have to add up to 360. So all we got to do is literally write each angle plus each other is going to be equal to 360. An equation that looks something like this, and all you have to do is combine like terms.